So I picked the harder of the three tables problems to work for you. A train runs back and forth on an east-west section of a railroad track. Train A's velocity measured in meters per minute is given by a differentiable function velocity of A of t, meters per minute, where t is measured in minutes. Selected values are given in the table. So question A asks you a very straightforward question that you'll see a lot. Find the average acceleration or average rate of change. If you have velocity, acceleration is just a derivative. And how do you find an average derivative? It's just the slope formula. So you're going to find the velocity at 8 and subtract it from the velocity at 2 over 8 minus 2. That's just slope formula, change in y over change in x. So my velocity at 8 is negative 120 minus my velocity at 2 is 100 over 6, which is going to give me negative 220 over 6. It did not say indicate units of measure, and I'm not going to simplify it. If I wanted to simplify it, I'd get negative 110 over 3. If I wanted to write the units, it would be meters per minute squared. But if it doesn't, it's meters per minute over minutes. So it would be meters per minute squared, but because it doesn't ask it, I don't want to put it. Part B says, do the data in the table support the conclusion that train A's velocity is negative 100 meters per minute at some time between 5 and 8? Give a reason for your answer. So my train's velocity at time equals 8 is negative 120. My velocity at time equals 5 is 40. Do I have to go through negative 100 to go from 40 to negative 120? I do if my function is continuous. This problem doesn't tell me straight up that it's continuous, but it does tell me that it's differentiable. So because v of a is differentiable, then continuous. And my velocity at 8 is equal to negative 120, which is less than negative 100, which is less than 40, which is my velocity at time equals 5. So because negative 100 lies between negative 120 and 40, therefore, by IVT, my velocity at some time has to equal negative 100 on the interval from 5 is less than t, which is less than 8. So I wrote down in pen some things that you should be looking at when you're looking at the problems. Now, problem C says, at time equal 2, the train's position is 300 meters east. So at time equals 2, here's my origin station. At time equals 2, my train's position is 300 meters east of origin station, and the train is moving to the east. Write an expression involving an integral that gives the position of the train from origin station at time equals 12, and then use a trapezoidal sum with 3 subintervals indicated in the table to approximate the position of the train at time equals 12. So this is, we've gone over this a bunch of times in here. Where you are is where you start plus how far you go. So if you want to know your position of your train at time equals 12, so your position of train A at time equals 12 is equal to your position of train A at time equals 2 plus the integral from 2 to 12 of your velocity of train A. Where you are at time equals 12 is where you started at time equals 2 plus how far you went, which is, if you integrate velocity meters per minute, it's going to give you meters. So it started 200 meters east from origin station. So this is going to be 300 plus. Now, if I'm going to integrate this using a trapezoidal approximation to find the area of a trapezoid, area is equal to height divided by 2, base 1 plus base 2. So let's go to the top and let's look and see if our heights are the same. So I'm going to scroll up, boop, boop, boop. So if I'm finding the area between 2 and 12, my height here is 3. My height here is 3, but my height here is 4. So height is equal to 3, height is equal to 3, height is equal to 4. So I can't write height divided by 2 and just add all my bases. I'm going to have to do it separately. So I'm going to do 3 divided by 2 plus 3 divided by 2, height divided by 2, base 1 plus base 2 is 140. Plus 3 divided by 2, base 1 plus base 2 is negative 80. Plus 4 is my height here divided by 2. And then base 1 plus base 2 is negative 270. And because I'm trying to get this done in under 15 minutes, I'm just going to, this was a non-calculator problem because it was problem 3. But this would be 2 goes into 140, 70 times 3, and then divide, multiply, add them all up. And you're going to get that the train's position is negative 150. Where you are plus how far you went when you found the area using the trapezoidal rule. Now, most of the reason I did this one is for part D. A second train, B, travels from origin station. At time t, the velocity of this train is given by this velocity function. At time equals 2, the train is 400 meters north of the station. Find the rate in meters per minute at which the distance between train A and B is changing. So train B is traveling north. So I drew a little picture here. So we had our train that was going east-west, and now we have a train that's going north. Find the rate in meters per minute at which the distance between train A and B is changing. So A is heading east, B is heading north, and you're trying to find the rate of change of the distance. So d, dt, when t equals 2. Now remember, normally your when, and you have your velocity for both of them. So you know the velocity of, you know a derivative is a rate. So you know velocity of A and velocity of B. Velocity of A is in the table. They gave you velocity of B. And they're derivatives, they're rates. We're trying to find d dt when t equals 2. Well, we know that train A at time equals 2, they told us here is 300 meters east. So A is equal to 300 meters east. And they told us here that train B is 400 meters north. So train B is 400 meters north. What's my equation going to be? Train A is moving, train B is moving, and the distance between them is moving. This is not like the ladder problem. So because everything's moving, this is going to be A squared plus B squared equals D squared. And I can't plug in any numbers because everything's changing. So when I take a derivative, remember you always take a derivative with respect to time, d dt. So 2a dA dt plus 2b dB dt equals 2d dd dt. I'm going to go ahead and get rid of those. Now, I need to plug in A, B, and D, and I also need dA dt, which is just velocity of A, and dB dt, which is velocity of B at time equals 2. So I know A is 300, B is 400. That means D has to be 500, 3, 4, 5 triangle. So I'm going to start substituting in what I know. So I know A is 300. And then velocity or derivative of A at time equals 2. I'm just going to go up here, and it's just 100. My velocity of train A at time equals 2 is 100. So that was 100, and I got it from the table. That's 100. Plus B is 400. And then the velocity of B is what you get when you plug in 2 here. So that's going to be -5 times 4 plus 60 times 2 is 120 plus 25. So -20 and 25 is 5, so that's 125. Is equal to D is 500 times dd dt. So if I divide both sides by 500, I get that dd dt is equal to 160. So not sure how the grading is going to go this year, but I'm going to go back and I'm going to grade this one real quick. Problem here was just worth +1 for your average rate of change. This one was worth 2 points. You had to have 1 point for, at some point, stating that you knew that -100 was between -120 and -100. And then +1 for IVT. Then problem C was worth 3 points. 1 for the position expression. So just for writing this out, where you are is where you start plus how far you went. 1 point for having your trapezoid sum, and then 1 point for your answer. And then problem D was worth 3 points. You got 1 point for knowing this was the equation and taking a derivative by using implicit derivatives. So that was worth 2 points for just taking a derivative with respect to time, and then 1 point for your answer. So thank you.